it was good, man. I'm just kidding.
As part of our general effort to make the game look and feel better, one of the things that has been bothering me is the fact that our vials of experience aren't animated at all. They just kind of disappear when the player collects them. So let's make that a little bit more.
This was all we could say.
Holy cow. How's everybody doing? Still got my sexy morning voice. Is it getting you excited? Those my levels. This song's kind of loud. Okay, just gonna keep going back.
Satisfying. Let's open up our vial experience, or our experience vial rather, and we'll take a look at this scene. And let's open up the script. So we're emitting this experience vial collected and then Q freeing the vial. And that's what's kind of unsatisfying, is that it's just disappearing. What we're going to do is we're going to make it actually fly toward the player, and perhaps we'll give it some sort of rotation or something of that nature as well. So we're going to be using tweens again for this, and the reason is because it's very easy to use tweens to animate between two variable positions. And in this case, we're going to animate between the position of the experience vial to the position of the player, but keeping in mind that the player position will vary. In other words, it will change while the player is moving and the vial is flying toward the player. In our on area entered signal, let's start by creating a tween. Var tween is equal to create tween. And what we're going to do is we're going to say tween dot tween underscore method. Let's call it tween underscore collect. And before we go any further, let's create that function. So func tween underscore collect. We're going to send in a couple of arguments here. First, the thing that's going to come in is our interpolated value from the tween, which in this case is going to represent percent, which is of type float. And then we're going to pass in the start position, which is going to be of type vector2, and actually that should just be fine. So just the start position. And you'll see how this is all going to work in a second here. So let's just write pass. So we've got a tween collect method, which is going to be past the percent, which is what we're going to be tweening, and then our start position. So this is how this is going to work. So we've got tween method, and if we control click into this, we can see that what we need to do is pass in a callable, which is basically a reference to a method, which we've set up, and a from and a to and a duration. And so what I like to do for this kind of thing is we have the tween collect. We'll revisit that tween collect in a second here. But I want to go from 0.0 to 1.0 because this is from 0% to 100%, basically. And then our duration, let's do something like, let's just do 1 second. That should be fine. Now with this tween collect, what's going to be passed in guaranteed is this percent, which will be anywhere between 0 and 1 depending on how far the tween is in progress. But we also want to pass this start position, and in order to do that we have to do this. We need to write dot bind, and then our start position is going to be our global position currently. Now what are we going to do with this information? So we're storing a snapshot of the global position of this experience vial at the time that it is collected by the player. This will be passed in every single time as a position to tween. Collect. And in here, what we're going to do is we're going to grab the player. Var player is equal to get tree dot get first node in group player. If player is equal to null, we'll just return right out of that just for safety purposes. And then we've got this percent, and we're going to use vector2 lerp again. So we're going to take the global position of the node currently is equal to start position, so this is the position at which the vial was when the collection started, dot lerp to the player dot global position, And our weight is going to be the percent value that's coming in to the method. So in other words, we're using the tween to control the duration, how long it takes to go from 0 to 1%, and we're passing that in to the lerp and using that to calculate the new global position. And so you can imagine that it's going to take a number of frames for the collect animation to finish. While that's happening, the player is going to be moving. And so we have to constantly be using the lerp between the player position, and we have to use the start position as the root. We can't use the current global position because that would not make our animation work well. So that's what we're tweening. And then we can do something like this. So we can write tween callback, which will call a method after the previous tweener is finished, and we're going to call queueFree. And actually, let's do this. Let's create a new function called collect, and in here we're going to call queueFree. But above that, we're going to use this game events emit experience file collected. So cut that and paste it there. Make sure to remove the queueFree from this on area entered. And then in this tween callback, let's use collect instead. So this tween method is going to run for 1 second. It's going to lerp between the position at which it was picked up to the player position every frame using the percent that's passed in. And then it will call collect, and we should be good. So let's go ahead and run the game and see what that looks like. We need to collect some vials. So let's kill some rats, and there you go. So you should start seeing that the vials are collected now when you run over them, but they still don't look super cool. So what we can do is there's additional stuff we can do with these tweens. We can set easings and we can set transition types. This is a very handy website. This is called easings.net, and I will link this as a resource to this lesson. And what this does is this shows you a graphical and interactive representation of all of the different easing functions. Now, easing functions are something that are very common across all kinds of animation and game development software. So these are more or less standardized. And the nice thing about this is that you can hover over it to see what the behavior looks like. And so we can use this to figure out how do we want our vial to swing towards us. And what I'm thinking is we might use an ease in back like this so that the vial kind of gets shoved away from the player at first and then comes back. So let's use the ease in back, and you can hover over it to see exactly how that's going to look, or what that's going to feel like at least. So we go back to Godot, and here what we can do at the end of this tween method is we can call dot set ease, and then it will give you some auto suggestions. We're going to use tween ease in because going back to our ease in back, right? The ease type is in, and then the transition type will be back. So we're going to go to that line again. We've got set ease, and then we write set trans, and then tween dot trans back. And this line is a little bit big. For me on my end. So one quick tip is you can use a backslash to denote a new line. So you can make multi-line statements by doing a backslash and then continuing on the next line. The duration, how long it takes to go from 0 to 1%, and we're passing that in to the lerp and using that to calculate the new global position. And so you can imagine that it's going to take a number of frames for the collect animation to finish. While that's happening, the player is going to be moving. And so we have to constantly be using the lerp between the player position, and we have to use the start position as the root. We can't use the current global position because that would not make our animation work well. So that's what we're tweening. And then we can do something like this. So we can write tween callback, which will call a method after the previous tweener is finished, and we're going to call Q3. And actually, let's do this. Let's create a new function called collect, and in here we're going to call Q3. Here you go. So you should start seeing that the vials are being collected now when you of all of the different E. So we go back to Godot, and here what we can do at the end big for me on my end. So one quick tip is you can use a backslash to denote a new line. So you can make multi-line statements by doing a backslash and then continuing on the next line. And so what this is saying is this is essentially all supposed to be on the same line, but because Godot uses white space as a way to determine what blocks are, you actually need to mark when a white space line should be a continuation. So we've got the set ease and set trans. So let's go ahead and see what that looks like when we collect a vial from a rat. All right, that looks really great. So let's turn the duration down to 0.5 instead of 1, so that's the third or the fourth argument here, rather. Let's rotate the vial according to the direction that is between start position and the player's global position, or our current global position, let's say. So we want to say, let's create a new variable, var direction from start underneath the global position is equal to global position, so the current global position minus the start position. And now we're going to set the rotation. So we're going to say rotation is equal to direction from start dot angle. Now what I'm going to do is I'm going to comment out this game events emit experience vial collected line, and then I'm going to open up my basic enemy scene, go to the vial drop component, and turn the drop percent up to 1. And the reason why I'm doing both of those things is just so that we can test the vials without having to be interrupted by either waiting for a vial to drop or by leveling up. So let's see what this looks like. And you can see that the rotation starts to work, but there are a number of problems. Component, and turn the drop percent up to 1. And the reason why I'm that is between start position and the player's global position, or our current global position, let's say. So we want to say, let's create a new variable, var direction from start underneath the global position is equal to global position, so the current global position minus the start position. And now we're going to set the rotation. So we're going to say rotation is equal to direction from start dot angle. Now what I'm going to do is, and turn the drop beacon test up to enemy scene, experience vial collected line. And then I'm going to open up my basic enemy scene, go to the vial drop component, and turn the drop percent up to 1. And the reason why I'm doing both of those things is just so that we can test the vials without having to be interrupted by either waiting for a vial to drop or by leveling up. So let's see what this looks like. And you can see that the rotation starts to work, but there are a number of problems. It looks a little bit weird. It's not quite clear why it's not looking right. And so there's a little bit of weirdness. So the first bit of weirdness is that when we're using this angle, so this is an angle in radians, and it can go from positive to negative by crossing a certain threshold, which flips the entire thing around. And so we could take steps to address this. First, let's get it facing the right direction, because you'll notice too that the vial is facing straight up and down, and that's a problem because remember 0 degrees is represented by being to the right. And so when we rotate it to say face, let's say we wanted it to face up, right? We want to say face in the up direction. It's actually going to be rotated like this because that's 90 degrees. You can see my rotation is -90 right there, right? And so that's a problem. So what we need to do is we need to rotate it by 90 degrees additionally. So the way that I'm going to do that is I am going to firstly say rotation degrees. So rotation underscore degrees is equal to, let's do a function called rad2deg, which will convert radians to degrees. We'll take that direction from start angle and put it in there. And then we can add 90 to it so that we can get that offset working. Okay. And then the other weird thing is our tween is actually being started twice because this area 2D is being entered twice by our player. So when the vial flies back, when we collect it, it exits the player's detection range and then it flies back into the player's detection range. And that is causing the two tweens to start, which are fighting with each other. And that's why it's never quite ending up at the player's position. And so what we can do to fix this is we simply need to disable the collision shape when the area is first entered. So let's go ahead and do this. In the top here, we're going to do an on ready, and I'm going to use this neat little trick. I'm going to click and drag on the collision shape 2D in the area 2D. I'm going to bring this over, and then I'm going to hit control and hold control and then release my mouse button, and that will generate an on ready for me for the collision shape 2D. Now in the on area entered, we want to set the collision shape 2D equal to disabled. However, we cannot do that in a physics callback. That will give us an error. You generally speaking cannot modify anything about collision shapes in an on area entered or on body entered signal. That is a special event that Godot warns you against modifying. Let's do this. Let's create a function called disable collision. And then we're going to say collision shape 2D dot disabled is equal to true. And then in our on area entered, let's do callable and then in parentheses a reference to disable collision. And then we're going to call dot call deferred. So what this will do is this will say, okay, we want to call this method here, but on the next idle frame, so outside of this physics collision process. So now let's go ahead and collect some vials and see if that looks a little bit better. All right, so that's looking much nicer. Now we're going to call dot call deferred. So what this will do is this will say, okay, we want to call this method here, but on the next idle frame, so outside of this physics collision process. So now let's go ahead and collect some vials and see if that looks a little bit better. Create a function called disable collision. And then we're going to say collision shape 2D dot disabled is equal to true. And then in our on area entered, let's do callable and then in parentheses a reference to disable collision. And then we're going to call dot call deferred. So what this will do is this will say, okay, we want to call this method here, but on the the next idle frame. So outside, we want to call this method here, but on the next idle frame. So outside of this physics collision process. So now let's go ahead and collect some vials and see if that looks a little bit better. All right, so that's looking much nicer. Now we're still getting some weirdness with the rotation. I think it's mostly looking okay. It's just, it's pointing in the opposite direction when it does the first back. So we can fix that. And I think the simple fix for that is just going to be to always point it at the player position. So instead of pointing from the start position to the current global position, let's point from the start position to the player.global position. Let's see if that works. All right, that's looking good. And let's make this a little bit smoother by interpolating the rotation degrees. So let's do this. Let's create another variable called target rotation degrees. Let's copy this line, or cut this line rather, and set the target rotation degrees equal to that line. And then we're going to say rotation degrees is equal to lerp, which is just a normal function, which allows us to lerp between floats. Let's lerp do this. Let's see if that works. All right, that's looking good. And let's make this a little bit smoother by interpolating the rotation degrees. So let's do this. Let's create another variable called target rotation degrees. Let's copy this line, or cut this line rather, and set the target rotation degrees equal to that line. And then we're going to say rotation degrees is equal to lerp, which is just a normal function, which allows us to lerp between floats. Let's lerp between the current rotation degrees value and the target rotation degrees. And our weight, let's do that trick again, 1 minus exp, and then let's do negative get process delta time. So again, this is the which allows us to lerp between in floats. Let's lerp between the current rotation degrees value and the target rotation degrees. And our weight, let's do that trick again, 1 minus exp, and then let's do negative get process delta time. So again, this is the frame rate independent lerp that we've been using. And we don't actually want to use lerp. We want to use lerp angle instead. And the reason is because this is essentially a special method that will handle smoothly interpolating between when it flips. So there's a point where once you rotate past a certain point, the sign of the angle actually flips. And if you don't use lerp angle, then you will see your angle just flipping instantly. At one point. So you can play with it, you can use lerp and see what I'm talking about, but lerp angle is what you should be using when you're lerping angles. And when we use lerp angle instead of lerp, we actually have to convert these degrees to a simple rotation. So let's change all of these degrees then to rotation. So that's in radians equals lerp angle. We're going to do rotation, so from our current rotation to, and instead of calling this target rotation degrees, let's rename this by highlighting it and hitting Control D, target rotation. So that will rename both at the same time. And then we'll get rid of this rad to deg. And we'll instead put deg to rad around the 90. So that we can get 90 degrees in radians. All right, let's see how that looks. That's looking great. I'm really happy with how that's looking.
Oh, that thing is spinning.
And we'll instead put deg to rad around the 90 so that we can get 90 degrees in. In radians. All right, let's see how that looks. That's looking great. I'm really happy with how that's looking. And we'll instead put deg to rad around the 90 so that we can get 90 degrees in radians. All right, let's see how that looks. That's looking great. I'm really happy with how that's looking. Add around the 90. So that we can get 90 degrees in radians. All right, let's see how that looks. That's looking rid of this rad to deg. And we'll instead put deg to rad around the 90. So that we can get 90 degrees in radians. All right, let's see how that looks. That's looking great. I'm really happy with how that's looking. I'm going to make one change in here, and instead of doing exp negative get process delta time, I'm going to do -2 times get process delta time, just to make it go a little bit faster in terms of the rotation. All right, that's looking great. So now we've got a good amount of motion in our experience vials, and that's looking a lot better now. And one final thing that we can do to make this look a little bit better is we can actually scale the vials out so that it looks a little bit smoother, like they're being collected. So the way that we need to do that is let's go to our tween and let's do tween.setParallel. Now, what tween.setParallel does is it will run all of the tweeners in parallel. So this is one tweener right here. We're going to create another one, which is tween.tweenProperty. We're going to tween the property of the sprite 2D. So let's go ahead and grab an on. Actually scale the vials out so that it looks a little bit smoother, like they're being collected. So the way that we need to do that is let's go to our tween and let's do tween.setParallel. Now what tween.setParallel does is it will run all of the tweeners in parallel. So this is one tweener right here. We're going to create another one, which is tween.tweenProperty. We're going to tween the property of the sprite 2D. So let's go ahead and grab an onReady reference to the sprite 2D here by dragging this over into the editor and then holding Control to do onReady, or you can type it out if you prefer. And I'm going to actually call this sprite instead of sprite 2D. So back down to this line, tween.tweenProperty, we're going to tween sprite. The property that we're going to tween is scale, in quotes. So if you're unfamiliar with what the property is called, you can just scroll down into the editor here, scroll down to transform. If you hover over it, it will tell you what the property name is. So that's scale. And then we are going to say we want to transition to vector 2.0. So this is our final value here. And we want it to be a duration of, let's say, 0.15. Now, the problem here is that when we have set parallel, both of these are going to run at the same time. And so is this tween callback, which is not what we want. So to fix the tween callback being called too early, we can do tween.chain. And what tween.chain does is it says, wait for all of the previous tweens to finish before moving on to the next tweens. So now our collect will only be called when both of these are finished. But we still have the problem of this 0.15 seconds is quicker than the 0.5 seconds we have up here. And because these are running into parallel, that means that it will tween out before it has a chance to do any of this animation really. And so what we're going to do is I'm going to set a delay here. So I'm going to say set_delay, and I'm going to set the delay to 0.35. And so this is going to say, wait 0.35 seconds before you animate this thing and take 0.15 seconds to do it. And that will add up to be 0.5 seconds total, which is the same value as this. All right, let's go ahead and run the game and make sure that this is working as we expect. Now the vials should be fading out to nothing. And if that's a little bit too quick of a fade out for you, I think it is for me, I might see if I can get away with 0.05 for the scale duration and then change this to 0.45 delay. All right, it's very subtle, but sometimes subtlety is all you need. I really like how that looks. It doesn't abruptly leave existence anymore. You can see a few frames of it actually sliding out. It kind of looks like it's going to the player's inventory, so I think that looks really nice. Okay, so that was a long lesson, but that is a good introduction. Few frames of it actually sliding out. It kind of looks like it's going to the player's inventory, so I think that looks really nice. Okay, so that was a long lesson, but that is to the player's inventory, so I think that looks really nice. Okay, so that was a long lesson, but that is a good introduction to tweens and how powerful they are. It's a nice way of animating things in code, and like I said, doing things in a way where you might have variable parameters. I mean, think about doing this with an animation player. How would you make a vial travel toward the player, pointing in the direction of the player, if you weren't using a tween? That would be almost impossible, if not outright impossible, to accomplish with a plain old animation player. So this is where tweens really shine. And before I conclude the lesson, let's uncomment out our game events.emit experience vial collected, and then let's go back to our basic enemy and make sure to put this drop percent in the vial drop component back down to 0.35 or whatever number you feel comfortable with. And let's just do a quick verification that we can still level up. All right, perfect. Everything is working. And that's it for vial pickup animations. One thing that has been visually lacking so far is our UI, and most notably we're using the default Godot font, and we need to update this experience bar to look nice, and all of our panels for upgrade cards don't look that great either. So the first thing that we're going to do is we're going to set up a theme with a default font of our own. So I've linked
take a break.
the download page for a set of
Before I do this font stuff. Really can't wait till I get to the end of this tutorial, because that's when I'm gonna start you know, really customizing the game to be, you know, what I want. So it's very exciting. I'll be back though. I'll be back in a bit. Just gonna go for a quick walk to get my blood going.
And pretty sure to see, not to change something, but just to experience it for the first time again because of how much it meant to you to do that scene. What would be the scene you'd want to relive? I would want to reshoot the scene with you in the first movie. So when we shot outer space,
Okay, I'm back. I'm back.
Public domain fonts that you can use in your projects for this project and for all future projects. I've also uploaded the zip standalone, so please check out the itch page of the author of the fonts, but you can also just download the zip file directly from the resources in this lesson. And once you've downloaded that NB pixel font bundle, go ahead and extract it wherever you want. And I'm going to use this Rockbox Cond 12 font. And so I'm just going to go ahead and drag that over into the Godot file system, and that's going to put it right there. Now it's not going to stay there. So let's go to resources.
What do you guys think? Which one should I use?
And let's create a new folder underneath this, and we're going to call this theme. And then I'm going to drag this TTF file into the theme folder, and then I'm also going to right click, say new, and then resource, search for theme, and add the theme here, and you can just call it theme.tres. Okay, so what is a theme? Well, a theme essentially say new, and then resource, search for theme, and add the theme here, and you can just call it theme.tres. Okay, so what is a theme? Well, a theme essentially is a way that we can dictate how all of the UI assets look by default. And you can see in here that these are our default UI elements. They're already all built out nice and neat for us. And this is also a nice way to preview any changes that we make. And so you'll actually see the fonts in here change when we change the font. Before we go any further, because this is a pixel art game, we need to make a couple of changes to the font itself. So if you double click the TTF file, this will open up this window. And there's a couple of options here that we want to pay attention to. Anti-aliasing. Since this is a pixel game, we don't want any anti-aliasing, so turn that to none. Okay? And then we're going to turn hinting to none as well. And then sub-pixel positioning, we're going to turn to disabled. Okay, so with all those settings set, we are going to have nice, crisp pixel fonts in our game. Let's click re-import, and we should be good to go. So now I can drag over this default font, so I can open my theme by double-clicking. I can drag the default font into the default font property, and then the default font size should be 16 because these NB pixel fonts, almost all of them should be scaled in multiples of 16 in order to preserve the pixelness of it. Okay, but you'll notice in our game, this font is still wrong. And the reason is because we need to set the default font for the project wide. And so what we need to do is go to Project, Project Settings, and make sure Advanced Settings is on, so toggle that on there. And then go to the Filter Settings box and type Theme. Go to the GUI Theme section, and we have Custom here. This is a custom theme. And when we supply this path, it's going to update all of our control nodes to use this theme. So I'm going to go ahead and open this up, and then I'm going to go to my resources, theme, and theme.tres. So again, you click the open icon here and then point it to the path of your theme. Now this does require a restart, so I'm going to go ahead and restart. All right, I've restarted my editor, and you can see now, look at this. Our little test text right here is correct. It's showing that font that we specified that we wanted to use. So let's go ahead and run the game, and that's looking great. That timer at the top of the screen is not super readable. So let's go into our Arena Time UI, and let's go ahead and add a outline around this text. So if I go to my label here, and I scroll down until I see the theme overrides here. Our upgrade here. What I can do is I can change this shadow offset and outline size to give it shadows and outlines. I'm going to choose outline by clicking on the box here and then enter 2, and then I'm going to check the box that says font outline color. So now we can see the font outline, and I'm going to hold control and just scrub with the left mouse button this value until I get something that looks approximately like what I would expect to see in the asset pack. And remember, our asset pack has like really thick outlines, somewhat like that. And so the option that I'm using is an outline size of 10, and I think that looks really nice. The final thing that I want to do is I want to change this font outline color to match the brown that the other outlines are using. And so what I'm going to do is I have a color picker tool in Windows, but I will read the color to you as I input it. So I've just copied the color. I'm going to bring it over to the font outline color and select this color bar and paste it in there. And the hex code is 3F2631. And so hit enter to apply that. And now we've got our text with a brown outline. And so if I go back into the game, you can see now that that text is a lot more readable. So that was a brief introduction to themes and fonts. Next up, we are going to do something fun. We are going to use what we've learned about fonts and themes to create numbers when an enemy gets hit. And then afterwards, we'll begin work on our other UI elements. Something that is a must-have in these kind of games is doing a hit flash when an enemy gets hit, as well as spawning a nice big number that shows you how much damage you did. Even though that doesn't sound like a lot, it's going to add so much to the feel of our game. The first thing that we're going to do is we're going to create a floating text scene that can spawn numbers in accordance with the damage that was done. So let's get started. Let's create a new scene, and we're going to make it a root type of Node2D. Let's call this floating text, and let's save it. And let's save it in scenes, and we'll put it in the UI directory and save. Okay, so the first thing that we want to do is we want to click Add Child Node, and let's create a type of label. And then let's write some sort of damage. Going to do is we're going to create a floating text scene that can spawn numbers in accordance with the damage that was done. So let's get started. Let's create a new scene, and we're going to make it a root type of Node2D. Let's call this floating text, and let's save it. And let's save it in scenes, and we'll put it in the UI directory. And save. Okay, so the first thing that we want to do is we want to click Add Child Node, and let's create a type of label. And then let's write some sort of damage. 700. Now what we're going to do is we are going to set on the label, we are going to go to the custom minimum size, set it to something like 200 wide, or let's do 150 wide. Actually, sorry to keep going back and forth, 100 sounds good to me. And then let's do 32 in the Y. And the reason that I'm doing this is because this gives me a known size so that I can center it properly. We are going to go to the custom minimum size, set it to something like 200 wide, something that is a must-have in these kind of games is doing a hit flash when an enemy gets hit, as well as spawning a nice big number that shows you how much damage you did. Game that can spawn. Let's get started. Node to save it, and let's save. Add child node. Write some sort of we are going to custom minimum size. Set it to something like 200 wide, or let's do 150 wide. Actually, sorry to keep going back and forth. 100 sounds good to me. And then let's do 32 in the Y. And the reason that I'm doing this is because this gives me a known size so that I can center it properly. So firstly, I'm going to change my horizontal alignment at the top to center and the vertical alignment to center as well. And since I have this custom minimum size, I actually know what my proper position needs to be in order to have this centered. And that is 100 divided by 2 in the position. So transform position, 100 divided by 2, and this has to be negative 100 divided by 2. And then we can do negative 32 divided by 2. And now my label is right in the center, exactly where I want. And actually, I think this font is actually a little bit tall, so I can hold control and drag on the position to center it just a little bit. So negative 14 is appropriate here for the position. So now that's centered. And the good thing about this is that we can have pretty large text and it will always be centered. Whereas if I did this, you can see now it's off-centered because it's extended in its direction, right? And so that's what we're trying to avoid by giving it a fixed minimum size. And before we go any further, let's go ahead and add a outline to this. We're going to make the outline a little bit smaller than the outline we did previously though. So I'm going to scroll down to the theme overrides, turn on font outline color, and then turn on outline size and make the outline size something like, I think 2 will be appropriate. And then I'm going to open up my Arena Time UI scene with Control-Shift-O. So here's the Arena Time UI. I'm going to click the label in the scene tree there and go ahead and copy this color by clicking on the color bar and then copying this hex code. Now, what you can also do if you want is I can go to the swatches drop down right here and I can click the plus button, and now this color will be saved in other color pickers so that way I don't have to copy. So if I go back to my floating text now and then I change this font outline color by clicking into it, I can expand the swatches and then click on that color, and there we go. We are going to want to animate this now. And we can animate it one of two ways. We can use an animation player, or we can use a tween. I think we've got enough exposure to animation players so far in this course, so I'm going to do tweens again and talk through them again because I think they are a really important tool to know. So let's go ahead and create a script for this floating text. And the default location is OK. Let's override the ready method. And then let's create a new tween with var tween is equal to create tween. Now what we're going to do is we are going to animate the position so that it flies up, slows down, and then goes again. So let's do tween dot tween property. And we're going to tween the property of ourself. The property is going to be global position, and our final var or final value is going to be our global position plus, and then in parentheses, let's do vector2 dot up times 16. And then our duration is going to be, let's say 0.3. Okay, so this is a little bit confusing, and actually we don't want this to be in the ready method anyway. So let's create a new function called start, and then let's take a text value, let's say text of type string. And then let's move this tween code into there. And let's just write pass under the ready. method for now. Okay, so on start, let's do another thing before we continue with the tween. Let's grab a reference to our label with $label, and then say label.text is equal to the text that we're passing in. Okay, so now we're creating the tween. We're tweening our global position, so the root node's global position, and we are going to tween to the position that is directly up by 16 pixels, right? So that's the purpose. Of doing that. And let's use our easings cheat sheet again. So here's that easings page again. And what do we want to do? Well, we want the text to, what I want it to do is fly up really quick and slow down, hang at that position for a little bit, and then rise up some more. And so what I think we want is something like ease out cubic. So it's going to slide up really quick, slow down, and then we're gonna speed it up again by probably using something like ease in cubic. So we're gonna combine an ease out cubic with an ease in cubic right here. So let's go ahead, and I'm gonna do a new line with that backslash. I'm gonna say set ease, and this is going to be an ease out. And we're gonna set the transition type of cubic. Okay? And then the next thing that's gonna happen is tween.tween property. We're going to do self, global position, and then we're going to do this same line. So I'm just going to copy this global position plus vector2.up times 16, but instead let's do times 48. So essentially what this is saying is we're going to go from our current global position to our global position plus 16, and then we're going to go from there to whatever our current global position plus 48 is. Now remember, when you're supplying these parameters, these are being evaluated at the time you define them, which means that this global position is the current global position at the time that start is called. And so when we say global position plus vector2.up times 48, we have to keep in mind that by the time this one gets run, it's already going to be 16 pixels to the way of this position because of this code up here. In other words, it's not going to go an additional 48 pixels up because we're starting from the same position. I hope that makes sense. It's one of those things where you will figure it out the more you work with tweens. You'll see how they work. Okay, so I'm going to make this 0.4 seconds. I'm going to put another new line. You don't have to do this if you have plenty of room, but I'm going to put a new line marker or character right there. I'm going to say set ease. We're going to do tween.ease out now, or ease in rather, sorry. And then set trans tween.trans cubic. So this is going to go up and then hang around the middle. Middle point and then out. So before we go any further with this tween, let's get it hooked up so we can actually see it working. What I'm going to do is I'm going to open up my hurtbox component, and this is the thing that's going to be responsible for actually spawning this. its number. So let's create an export. Actually, let's not do an export variable. I'm going to show you an alternate way of loading scenes. So I'm going to say var floating text scene in my hurtbox component script is equal to preload. And preload is a function that essentially will have the scene that you're referencing loaded. So in here, I pass a path to a scene, and it will already have that scene loaded and ready to go, I believe even before this script fires the ready method. So the preload, let's go ahead and look at the documentation. Yeah, so the documentation says during runtime, the resource is loaded when the script is being parsed. So essentially, it's just going to guarantee that the scene is ready to use by the time your code is running in this script. So we want to preload, and we're going to preload the path that contains our floating text. So I'm actually just going to type in here floating text, and the suggestions are good enough that it knows that I want to load one of these things. Make sure you load the .tscn, and there's our floating text scene. So now we don't have to have a property cluttering up our property list here when we're using this hurtbox component across a bunch of enemies. Now, the one thing to be very careful of is that if you ever move the position of this floating text, then it will not be automatically updated in your script. You're going to have to go and manually change this string if the path of your floating text changes. So that's the downside of using preload in this manner, is you generally want to avoid hard coding resource paths if possible, but sometimes it's worth doing that, especially to declutter useless properties that you don't need to be exposing. So anyway, that's our floating text scene that we're preloading. And then on area entered. So in here, we can actually spawn the floating text. So what I'm going to do is I'm going to say var floating text is equal to floating text scene dot instantiate. And let's instantiate it as a node 2D. Let's say get tree dot get first node and group. And let's use foreground underscore layer. Going to go from our current global position to our global position plus on the floating text. So what I'm going to do is I'm going to say var floating text is equal to floating text scene dot instantiate, and let's instantiate it as a node 2D. Let's say get tree dot get first node and group, and let's use foreground underscore layer, and I'm going to say dot add child floating text. So we're adding the floating text to the foreground layer. Now you'll notice I'm not being defensive in here, which might be a good idea, but I think it's useful to show you what this looks like in a single line here. We don't have to do it piecemeal. We can do everything all at once, just like that. And I'm pretty much guaranteed that the foreground layer is going to exist. I guess I just want to emphasize that defensive programming is important and you should take the time to do it. But, you know, sometimes it's not super necessary. So I'm going to skip that for now. And then I'm going to say my floating text dot global position is going to be equal to the global position of this hurtbox component. So the reason that it's nice to attach this functionality to the hurtbox component is that we can just spawn the text at the position of the hurtbox, which is generally centered around the enemy that we're hurting. So the text is going to spawn basically at the center of the enemy. And then we can call floating text dot start, and what we want to pass in here is the damage. So hitbox component dot damage. Now, I want to do string, which is a function that turns a variant, or basically any type in Godot, into a string. And in here, I'm going to pass the hitbox component dot damage. And if all went well, we should start seeing damage floating up from our enemies when we hit them. Okay, so there's a lot more work to do. I think I changed my mind about the outline. The outline just looks inconsistent. Sometimes it's not super necessary. So I'm going to skip that for now. And then I'm going to say my floating text dot global position is going to be equal to the global position of this hurtbox component. So the reason that it's nice to attach this functionality to the hurtbox component is that we can just spawn the text at the position of the. It's going to spawn based. We want to pass in or component damage dot damage. And if all went well, we should start box up here. And then we can call floating text dot start. Okay, so there's a lot more work to do. I think I changed my mind about the outline. The outline just looks inconsistent now. And so I'm going to go back to my floating text scene, go to my label, click on the 2D tab so we can see what we're doing. And I think I'm going to use an outline size of 6. And while I'm here, I'm going to probably use that same outline size in this label in the arena time UI as well. So let's change that to 6. I think that looks a little bit more reasonable. Now the problem here, not to get too derailed here, but there's a little tiny gap right here, which is still gray. And so the way we can do that is I'm just going to turn on the shadow offset Y and the shadow offset X, and then turn on the font shadow color like that, but it's black. So I'm just going to click into it, click swatches, and then click the color. So now we filled in that gray, and we've shrank the size of the outline so it looks a little bit less egregious, and I think that looks really good. And we're going to apply this same shadow fix to our floating text as well. So let's go back over to our floating text and do the same thing. So check shadow offset Y and shadow offset X, and then change the font shadow color to that brown. And that will just make sure that there's no gaps. All right, let's go ahead and run the game and see how all that looks. All right, I think that's looking a lot nicer. It's a thicker outline, generally looks better, and is roughly the same as what you'd expect from an actual character in this pack. So there's a bunch of problems still with our floating text, so let's continue working on it. The first thing we want to do is we want to do tween in our floating text script, tween.tween underscore callback. Let's do queue_free, a reference. And don't forget, do not invoke queue_free like that. You just want to do a reference to queue_free. So that will free it. We also want it to scale in. So let's put some spaces in between these tweeners here so we can understand them a little bit better. So remember the last time we were working with tweens, we used the set parallel, and we're going to do the same thing here because we want to tween the scale of the number as well. So let's do tween.set parallel underneath the create tween, and then let's put a new line. We're tweening this global position over 0.3 seconds. Let's also tween.tween property, self, and then scale in quotes. And we want our final value to be vector2.1, which is a scale of 1, 1. And then our duration, we're going to make that also 0.3. Let's go back to our easings cheat sheet. And again, I will link this in the lesson resources. And what I want to use is I want to use an ease out elastic. So what that's going to do is that's going to actually exceed 1, 1 and then snap back. And it's going to look really nice. So ease out elastic is what we want to use. So I'm going to say set ease, tween type ease out dot set trans, and we're going to use elastic. Okay, and I'm actually going to do a new line. Here, just that we can see that easier. Okay, so now very important thing that you can't miss is we need to do tween.chain. If you don't do tween chain, all of these are going to run at the same time, and it's going to look very awkward. So tween.chain, again, waits for the previously defined tweens, and you can have any number of these, waits for the previously defined tweens to finish before moving on. Okay, and so we're going to tween the scale again. So what I'm going to do is I'm going to copy this scale tween lines here and put those underneath our second global position tween, and find tweens, and you can have any number of these, waits for the previously defined tweens to finish before moving on. Okay, and so we're going to tween the scale again. So what I'm going to do is I'm going to copy this scale tween lines here and put those underneath our second global position tween, and we're going to change this to 0.4 seconds as well. And going back to the cheat sheet here, I want to use, I think, an ease in cubic so that it maintains a fairly large scale and then ramps out very quickly. Actually, I might use ease in cubic will be good because we're dealing with 0.4 second duration. So ease in cubic is what we want to use. So here we're going to change this ease out to ease in instead for the scale. And then we're going to do tween trans cubic, just like so. Okay, now very important again, you have to call tween.chain here as well. Otherwise, this Q free is going to be called at the same time as the rest of these, and you won't see the second half of the animation. Now, this elastic might be a little bit excessive, but we can use back to get a lighter version of the elastic essentially. But let's see what elastic elastic looks like. You get cue free is going to be called at the same time as the rest of these, and you won't see the second half of the animation. Now this elastic might be a little bit excessive, but we can use back to get a lighter version of the elastic essentially. But let's see what elastic looks like. And it looks like that's not working. Unfortunately, it looks like we're not going to get the bounce that we're looking for when we're dealing with this sort of small scale. So what you can actually do is, instead of trying to get the scale tween to work in a very particular way within this system, we can actually create a separate scale tween to start. So I'm going to copy or cut this scale tween here, and I'm going to create a new scale tween at the bottom here. Var scale underscore tween is equal to create tween. And then I'm going to paste that. Let's do
Hey, if it isn't the long lost Monkey King. How you doing, man? I'm a Godot guy now. Join the Godot cult, bro. Oh, not the Godot cult. We're growing. You will be assimilated. Yeah, I'm learning some animation tweens. Here, let me show you what I got so far in my game. It's like a Vampire Survivor style game. I haven't added sound effects. There is some good music, but I turned it off during development because it's just a bit repetitive. But there's two types of missiles. The other one's not set to spawn yet, but basically it's going to be a score game, right? Kind of like Galaga, where it just kind of scales infinitely and you get more and more enemies attacking you. Right now my guns are kind of overpowered just for testing. The stuff I did today is I set up these little like experience capsule things to like fly at you when you go grab them. That's pretty good. Right now I'm doing the damage text. But as you can see, there's like basically you'll get a random choice of 3 upgrades every it's not totally set up yet. The UI is still a bit funky, but you'll get 3 upgrade choices. It'll be stuff like shield, speed, this axe ability, which will later be called the nipple ability, kipple ability, and you know, there's a sword, there's a cutlass, there's like 4 different abilities, and you just kind of upgrade your guns as you collect experience, and it's just one of those things that's infinite nipple ability. Well, the game's called Space Pirate, so it's like a pirate theme, and there's something called a kipple. Something like that. No, I don't know how to spell it. They would put it in their cannons. It's like these 2 bearings connected by a chain. 2 cannonballs. I think they had one in Pirates of the Caribbean. Here we go. Nipple. Knipple? Knipple shot. I think that would go in your gun. So it was like a musket bullet with a chain attached to it. I don't know. But anyway, that's what the ability is going to be called. I love this. This is like pirate weapons, right? And they're like, at the end they have AK-47, and it's like, yeah, modern pirate weapon. I mean, it's not like Jack Sparrow's weapon, but it definitely is a pirate weapon. So, you know, it's like the pirates off the coast of Kenya type of thing. Yeah, nipple shot, dude. The AK fits with the... Well, I'm just gonna call the frontal gun a blunderbuss. And I intend to make it so... Yeah, well, mobile generally. So definitely on Android. I feel confident I could do that. I initially wanted to do web, but a lot of the like GPU stuff in Godot doesn't work on web, so I'm kind of like giving up on web. And it's gonna be like a leaderboards kind of game with public leaderboards, which I kind of know how to implement already. So from there, I actually want to kind of, after I get the leaderboard set up in this, I want to go back and you can use the same account to log into both Familia and I want to put a leaderboard system into Familia as well. I think like when it comes to multiplayer games, it should be like you should do a game with a leaderboard first, and then a game with peer-to-peer, and then a dedicated server game, and then maybe a open world like multiplayer game, you know? Like that would be like the progression of learning how to make a multiplayer game. So you start with something simple like something with just simple HTTPS calls like this and a very simple authentication system. Like I'm probably just going to use Google's Firebase authentication for this. Either that or there's a couple other free services that are specialized in game features, but I kind of would rather learn Google's one. Amazon doesn't really have like as out of the box solutions, but theirs are way cheaper when they scale. So it's like kind of a catch-22. But I want to learn Google's just because I don't really feel like I'm going to ever go past the free tier anyway. So it's like, why would you worry about scaling, you know? And if I did, I would just like open another free Gmail and use that for like a different game or something, you know? Some kind of shady business like that. But yeah, this game is going to have on-screen controls and then mobile dual analog control. Or right now it's mouse and keyboard control. I'm going to set up the mouse and keyboard control. I'm kind of waiting to do the analog stick control because I want to do it at the same time as the on-screen control because they're basically going to be the same physics-wise and like whatever. They're going to be like the same, you know. The on-screen joystick will be the same ultimately as the actual joystick, so that'll help. But yeah, I've just been following this tutorial I found on Udemy and then kind of editing the game as I go. When I'm about 3/4 done with the tutorial, and whenever I'm done, then I'll just add a bunch of the stuff I kind of been anticipating. I just don't want to add too much of my own stuff until I'm done with the tutorial because I'm afraid he's going to do something in the tutorial that'll conflict with what I added. So I want to finish the tutorial first. I don't know on Godot though, and if you ever find this out, to deploy to iOS, would you have to like import your project into a Godot project like you do on RPG Maker and then export it? Because that, I mean, I'm sure I'll find that out eventually, but if anybody knows that, like LMP, if you figure that out, please let me know because I'm curious. Because I have a decent Mac, but it's pretty old and I don't know, I might be passing the point where I can upload new iOS games. Like I'm on the verge of it, so it would affect like the my development process if I found out that you need to use it needs to be deployed on a Mac. And also just to know like what version of Xcode is like the minimum version to upload new stuff to the iStore now. Because I think I have, my version was good last time I checked, but that was like 6 months ago, so. No, I know you need that supports the latest, yeah. So I might have to go to this campus and take a computer from them, from like job or something. But yeah, this game is going to be good. I'm really excited to add sound effects. I'm just waiting because the guy does that in the tutorial and I want to see how he does it. And the tutorial, this tutorial is super good. Like, the way he does things, it's like, it's not just like I learned how to use Godot. It's like I learned how to like structure code better from doing it. So. But yeah, I definitely would like to put this on iPhone. I'll definitely put it on Android though. Probably do a desktop release too. I won! Right now the winning condition is that you last until 5 minutes. So this is the menu. It's not the greatest, but you know, something. I made this for a game jam, so I just kind of pushed it out. I'll be right back. I gotta use the restroom and then I'll get back to this tutorial. Doing these numbers. After the number floating damage text, I'm gonna do flash enemy on hit, which is gonna be interesting because I'm gonna have to turn down my damage. Because right now I just one-shot everything, so you won't be able to tell. I might have to turn down my bullet frequency too. I was thinking about if I ever made this multiplayer, all my weapons would work fine except for this machine gun thing, because it's so many like coordinates for each freaking bullet. It'll just like get messed up on a multiplayer. I'd have to like change the main weapon to like a frontal laser or something. Something that's not like so much information to pass through a server, you know what I mean? I'd have to do like a Death Star beam type of deal. Plasma from Metroid, something like that. I couldn't do this machine gun thing that I'm doing. Anyway, I'll be right back. I gotta use the bathroom. Hey, Monkey King, I don't know if you're still there. Dude, Monkey King, what's your real name again? I forgot. Ramirez? Some Hispanic name. My death screen isn't here. I didn't notice that. I gotta re-implement that. I fell off the wagon sometimes. Is it Jeff Ramirez? Some other Mexican. I don't know if you're Mexican actually, I forget. No, it's the boss man. Oh, it's Jeff Bossman? Oh, Jefe. Jefe. I was like, Jefe? I'm such a gringo. Mi nombre es gringo número uno. Llamo uno gringo amigo. Hola fresa. If I watch YouTube, I mean, I watch YouTube. I just don't watch the same YouTube. They have like literally millions of hours of content. It's not a it's not a guarantee that we're going to see the same things. My YouTube is all like, hey, let me show you how to make a game in 5 seconds. And then it's some loser who doesn't know what he's talking about. Named Bizmaster Studios. Just kidding. Oh, Robin. Yeah, Robin. Is it Ramirez or Hernandez? Something like that? I forget. Yeah, I added some videos for the first time in like 4 months. They got some views. I still probably am gonna do like a... I still need to do that Android deployment video. Gonzalez? I'm like Ramirez, Hernandez. Gonzalez, is it with an S? It's not with an S, is it? That's not how you say it in Spanish. Oh, I guess I don't know what I'm talking about. What else is new, huh? What else is new? I thought Gonzalez, the Spanish, Gonzalez was a Portuguese spelling. With the S. And Gonzalez, some people have it with the E, Z. I'm pretty sure all the Mexicans, because I remember you're not Mexican if I'm not mistaken. You were some other Central American or something. Pretty sure the Mexicans all spell Gonzalez with the Z. Maybe it's a Mexican thing. Those crazies, those local Mexicanos. And I miss, one of the things I miss about San Diego is all the Hispanic people. We don't have that many here in Hawaii. I would always try to speak Spanish, and they were always so nice, despite how terrible my Spanish was. I had a friend from Spain, and I tried to speak Spanish to him. Holy shit, he was so pissed. He was like, don't ever do that again. Go to school. He's from Spain, Spanish. Maybe that's why it's more common in Mexico? I don't know. Maybe it's not more common in Mexico. Maybe I just have that, my own personal experience is unusual. These damn Spaniards. Yeah, dude. They're like, all my Mexican bros, I'd try to speak Spanish and they would like laugh and think it's fun. The Spanish people would get like offended. Think Z is more common? Yeah, I think so too. But all my Spanish friends would be like, because I knew, and most of the Spanish people too, it needs to be said, I knew them from like school and stuff or something. They're like international students at my school. But all my Mexican friends were like people I knew from working on a farm. So it's like a different, you know, socioeconomic tier of which we're discussing here. So the high educated ones might be more sensitive to something like that, where the you know, Mexican, I don't really know how to say it without sounding like an asshole, but the ones who didn't even really have a high school level degree didn't really. They were just happy that I was trying to be nice to them and talk to them. Okay. So I need to bring this up here. Hey, I converted LMP to the Godot cult. He said he's working on a game now. In Godot. Dude, Godot's tweens are like crazy what you can do. You can like do everything with code. And then it's almost like, why are you even using the engine at that point? That's what I figured out when I was experimenting with networking as well. Like, you don't really need to use any of their like tools, and their tools are actually more buggy. Transition. Elastic. Here we go.
Scale.
I gotta set the scale variable. Zero. I'm kind of getting better at typing all this random code, but I'm also not.
Underscore tween,
I mean?
so we'll rename that to scale tween, okay? And then what we're gonna do is we're gonna scale to vector. .1 times 1.5. So we go to 1.5 and in the X and 1.5 in the Y. And then let's change the duration to 0.15.
Yeah, brah. 1 times 1.5.
And then we're going to use the ease type out with the transition type of cubic. And then let's copy and paste this line. So it's 0.15 again, except we're going to go down to vector 2.1 instead of vector 2.1 times 1.5. And we're going to change this to ease in. And this tween is essentially going to run parallel to this other one, and it's only going to be a duration of 0.3 seconds. So this tween should be done by the time this scale here kicks in. So let's go ahead and run that and see how that's looking.
See how it looks. Did the answer, and we were like 60% Mexican indigenous and 20% Spanish. Where did my freaking pop? Oh. Oh, they're like there, but they're gone like immediately. You see them? My damage pop-ups, bro. That's not right.
All right, that's looking pretty good. I'm very happy with how that is looking there.
I must have done something wrong.
I think one thing that I'm gonna do is
Let me look at it. Compare my code to his. Tween, create tween. Three. Oh! He doesn't do 3 here. He does 1.5. That'll make a big difference. Or 0.15. 48, 16. 0.3, 16, 48, 0.4. Let's try it actually just with the 1.15. That should make a huge difference. It's so delayed. I think there's too many text. There's tween changes or something. Chains that I don't need. Why are you so delayed? Transcubic. Both of these are ease in. This is ease out, ease in. Time transelastic, these should be transcubic. That wouldn't make the difference though, but we'll do it. See what happens. Ease in, ease out, transcubic, transcubic, transcubic. Is there something going on with the debugger? Oh, there is. That's probably because there's a spelling error somewhere. Let's check to see what that is. Bound root. Step. Tween. Foreground floating text started with no tweeners. So I don't set up the tween early enough.
perhaps change this vector2.1 times 1.5 to times 2 and see if that becomes a little bit more apparent. That's looking really good. All right, and then one final thing is I'm going to change this 0.4 duration in the global position and scale up in that original tween to 0.5. So I'm going to highlight the 0.4, hit Control D to select both of them, and then do 0.5. And even a tenth of a second can make a huge difference in the feel of the floating text. All right, so this is looking really great. So play the game for a little bit and see how the number feels to you. I think the numbers add a lot. We're still not done with this sort of impact yet. We do want to do a hit flash, but before we do that, let's do one final thing. The numbers are kind of spawning on top of the rats, and now that I'm playing with it, I think that, sorry to keep going back and forth, but I think that the scale is a little bit too much. So I'm going to change the 2 to 1.5, back to 1.5 rather, and then in my hurtbox component, I'm going to offset this floating text in the script where we are setting the global position. I'm just going to go ahead and add, in parentheses, vector2.up times 16. So I'm just going to send it up 16 pixels. Position. I'm just going to go ahead and add, in parentheses, vector2.up times 16. So I'm just going to send it up 16 pixels so it's offset from the enemy a little bit. All right, that's going to be perfect, I think. So play around with that and see how that feels to you. I think it's
Hey, real mature Monkey King. I'm gonna eat food. I'm gonna turn off my camera and my mic. You don't need to hear my eating sounds. Be right back. I mean, I'll be here. I'm gonna be chilling.
Now, how about drums? An instrument everybody loves.
Alrighty, back in action. Hey, wrong camera view.
It's feeling really good. And like I said, we're not in position. I'm up in that original tween to 0.5. So I'm going to highlight the 0.4, hit Control D to select both of them, and then do 0.5. And even a tenth of a Control D to turns and start. So the text in duration, same time as the rest of these. This system well, I'm going to copy or cut this scale tween here, and I'm going to create a new scale tween at the bottom here. Var scale underscore tween is equal to create tween, and then I'm going to paste that. Let's do scale underscore tween, so we'll rename that to scale tween, okay? And then what we're going to do is we're going to scale to
That's it. Yeah, that's awesome. Look at it. I have a hit point system. I kind of wish it faded out a little bit more, not just like dropped off like that. I don't really know how to do the opacity tweens, just the size.
vector 2.1 times 1.5. So we go to 1.5 and in the X and 1.5 there. I change this vector 2.1.5 to times 2. Offset this floating text. In my hurtbox component, I'm gonna back to 1.5 rather. And then in my hurtbox component, I'm going to offset this floating text in the script where we are setting the global position. I'm just going to go ahead and add in parentheses vector2.up times 16. So I'm just going to send it up 16 pixels so it's offset from the enemy a little bit. All right, that's going to be perfect, I think. So play around with that and see how that feels to you. I think it's feeling really good. And like I said, we're not done yet. So let's get to the next part of this work in the next lesson.
I'm going to take a quick break. I know I just kind of took one, but...
Let's continue by making...
So now is to implement the flash on hit. I'm just gonna take a quick break. I'm kind of tired now, so I'll put on my away screen. I'll probably be back in like 15 minutes or so. Sorry, it's kind of like hit and miss. I'm just kind of tired. I had a busy day tomorrow. Be right back. 15 minutes. Hey, I'm back. All right, and on to the next little lesson here. Okay. I went to a party last night, and I was a bit. There was some drinking, so I'm a little bit slower today than normal.
A hit flash effect for our enemy. So in addition, there's a shader property here. Click the empty, and let's do an activity very quickly. This is a very common feature in games to convey to the player that damage has been done to the enemy. And so yeah, let's get right into it. We're going to take a component-based approach again, just so that we have a reusable component that we can use instead of duplicating code in a bunch of places. Now it's a little bit tricky, and you'll see why it's tricky in a little bit, but here's what I'm going to do. Let's create a new scene and give it a root type of 2D scene, and then let's call it a hit flash component, just like that. And then we can save that in scenes component. So we've got our hit flash component saved. Let's go ahead and create a script with the default settings is fine. And let's do an export variable. And what do we want to export? We want to export a variable that represents the health component. So let's do export var health component, and that's of type node. And then let's do another one, export var sprite, and that will be of type sprite 2D, just like so. Okay, so let's create a ready method override here, and we're going to take this health component, and we are going to connect to the health changed signal. So health component dot health changed dot connect on health changed. Let's create that function for on health changed, and let's just write pass in there for now. Let's take a look at our health component by opening that up, and our health component here, when it emits the health changed signal, it doesn't have any argument for on health. Changed, and let's just write pass in there for now. Let's take a look at our health component by opening that up, and our health component here, when it emits the health changed signal, it doesn't have any arguments. So we should be good with just the function with no arguments in our hit flash component script here. Now this is where things get a little bit tricky. Before we go any further, we need to write a shader. And so I'm going to go to the 2D mode here in the hit flash component scene. I'm going to add a child node that is of type sprite. Now this is just going to be temporary so that we can see what we're doing when we write our shader. And I'm going to search. You can use any sprite that you want. I'm just going to drag the wizard enemy over onto the texture just so that we can have something here. Okay, so select that sprite 2D and scroll down all the way to the bottom until you see the material property here. Click that drop down and then select new shader material, and then click into that, and there's a shader property here. Click the empty and then click new shader, and this path should be fine. You could create a different shader directory if you want for your shader, but I think we'll just leave it in the component directory. That's fine for me. So we're going to create and then click into that shader to open it up. And so this is our shader editor, and it should be pre-populated with these lines: shader type canvas item and void fragment. Shaders are one of those things that it's going to be impossible to describe them adequately in a single lesson. These are very complicated things that can take a long time to get a grasp of, but I'm going to do my best to get you introduced to the concept of shaders, and hopefully that can kick off some further learning for you. So this shader type line here is just telling us what the type of the shader is. For 2D applications, we want to use canvas item, which is what it defaults to. And then there's this void fragment, and this is a function that will be called on each pixel that exists in the texture. And there are a number of constants that come into the fragment function that we can reference. And this is all done under the hood behind the scenes. You can view this as a method that we're overriding to specify the shader functionality.
dance.
So the first thing that we should know about is
don't
the
think
color
the
constant, which
points
is an
work
all
anymore.
caps color. And this is the way that you set the color of the pixel. Remember, this fragment function runs
interesting,
for
the
every
shaders
pixel in the shader.
are like
so
JavaScript.
we could say color is equal to, now
It's a C++,
a color is
I don't know.
represented as a vec4, which is a 4 parameter or 4 element vector. And so we can represent that with vec4, just like so. And we can either supply 4 arguments here, or we can supply 1 argument, because that will be duplicated all across all of the arguments. And then we do need to end our statements with semicolons. And so if I just simply write this line, what I've told the shader to do is make every pixel in the texture white. Now you'll notice that that also affects the transparent pixels, because transparent pixels exist in the image, they're just transparent, right? Okay, so how does that help? Well, we essentially want to turn the sprite all white when an enemy gets hit, but we're not quite done with the shader here. So what we need to do first is we need to first grab the color of the pixel coming from the shader. And so let's create a new variable, and we're gonna say vec4, and in the shader language you have to specify the types that you are using. You can't just use var. So vec4 texture color, I'm going to call it texture underscore color, is equal to texture, which is a function, in parentheses, then in all caps texture, and then in all caps UV, and then put a colon at the end. Okay, and then let's replace this color line right here with texture color. Okay, so what is this line doing? We're saying let's create a texture color variable that is of type vec4, because remember, colors are red, green, blue, and alpha. So that's 4 channels. And then the texture function tells us, okay, we want to read the value of a pixel at the specified texture at the specified UV. Now this texture may seem like magic, but this is one of those constants that's coming into the function. So Godot already knows that the texture that's attached to this node is this texture here, and so it stuffs that texture data into this constant for us. And then the UV is essentially a coordinate, it's a vector 2, between 0 and 1 in the x and 0 and 1 in the y that represents the position of the pixel that we're looking at in the texture. And I guess that's just, I'm sure there's a lot of technical optimizations behind why UV is a 0 to 1 in the x and 0 to 1 in the y, but basically that's the percent from the left and the percent from the top that we're looking at. So 0, 0 would be in the top left corner here, and then 0.5, 0.5 would be in the middle. And again, UV is being passed in for us as a constant. So this fragment is being called essentially for each pixel or each UV coordinate within the texture. Okay, so what these two lines together are doing is saying grab the color of the current pixel that we're looking at and then assign our color output to that texture color. Okay, I'm gonna remove this comment because we don't need it. So this is a very basic 2-line shader that essentially just writes the texture to the screen. Okay, so how do we actually manipulate this texture? In our case, we want to make the sprite all white. And so how can we do that? To make our character or our texture all white, we can use the mix function, which is essentially the same as linear interpolate. We've used a linear interpolate in quite a few places already, and we can do the same in shaders. It's just the functions are called a little bit different, or they're named a little bit different. So we want to essentially mix between white and the texture color, because we want the flash to happen and then for it to fade out quickly, right? And so that implies that we need a transition or a linear interpolate. Okay, so how are we going to do that? Well, first let's write our line. So let's do vec4 final underscore color is equal to mix, and then open parentheses. We're going to mix our texture color, and we're going to mix to vector 4, and we're going to represent white. However, we're going to write 1.0 3 times for the RGB channels, and then the alpha, this is very important. We want to use the texture color alpha, so we can do texture color dot A for alpha, and then we can put, let's say, 1.0 as our third argument, and then end with a semicolon. Okay, and then our color output can be, instead of texture color, we'll call this final color. And now you should see that your texture is all white. Now, let me explain this mix line a little bit more. So we're mixing, which is linear interpolate. We're going from
1.0 final color equals mix. For 111 texture color A 10 error 5 sometimes. Expected comma. What the heck is going on here? What in Tar Heel Nations is happening right now? What language is this? Anybody know? Is it JavaScript? It feels like it. Is it just shader language? Shader script? Vec4 final color equals. Where did I mess up? Mix texture color vec4 111 texture color dot A 1.0 color equals final color. I don't see anything wrong with my code. I don't see anything wrong. GD shader file. Oh, there's the comma that I'm missing. There it is. Look at it. It's wide. It's so wide. Can't you see? It's wide. Look at the white missile. That's what it's gonna look like. It's a bit phallic, but don't tell anybody what that means because they might.
our texture color to white with this weight. And so if I turn this 1.0 at the end down to 5, or 0.5 rather, that will be halfway in between the texture color and pure white. Now, what is this vector 4 in here? Well, this vector 4 is a color, right? This is another color that we're representing. And white is a value of 1.0 in all the RGBA channels. But if we don't put our texture color in here, and we instead do 1.0, you can see that that now has filled in that entire box. So we need to use texture color dot A, which is how we reference the alpha channel of this color, which is a vector 4. And that way we can preserve the transparency of the pixels that are supposed to be transparent. Now, a quick word on accessing the texture color with this .A. I believe this is known as swizzling, and that is taking a certain number of the elements from a vector 4 by using this sort of dot notation. So I could say vec2 texture color is, or let's say vec2 example is equal to texture color dot AR. And what this will do is this will get me a vector 2 where the first component is the alpha value of the texture color and the second component, or the Y component, is the red channel value of the texture color. So I could say for this final color down here, let me remove this example line. For the final color, I could technically do this. I could do RGBA like so, and it wouldn't change anything because this is essentially constructing a new vector 4 with each element from each of these channels in that order. Of course, I don't need to do that though, but that is useful because there are some instances where you don't want to change the alpha value, and I want to say, for instance, here, I just want to change the RGB, so I could say color.rgb. Now I'm going to get an error because this is a vector 4 instead of a vector 3 like it is here. But I can do final color.rgb and so on and so forth. All right, so that's a little bit about mix. Now, what is this 1.0? This is how we control how bright our white is in our sprite. And this is where uniforms come in. This is how we're going to be able to control this value from outside of the shader. So let's do this. Let's do at the top, above fragment and below the shader type, we're going to say uniform float. We'll call it lerp %. And then we'll just go ahead and end that there. Okay, so now instead of this 1.0 at the end of this mix function, I'm going to put in there lerp %. And what a uniform is essentially a variable that we can set from outside the shader from something like GScript. So this is how you make your shaders variable. And the cool thing about Godot is if I scroll down to where my shader material is, you can see that under the shader parameters heading, the lerp % is now available for me to edit. And so I can actually put in a value here, and now you can see that it's changing over here. So I could do 1.0, and I can change it from the editor. Now, the other cool thing about uniforms in shaders is we can give them property hints so that we could, for example, constrain this range to be between 0 and 1. And so the way that we can do that in our shader is we can put a colon hint underscore range, and then let's do 0.0 and 1.0. And so now you can see my lerp % over here now has a little slider button where I can manually drag it between 0 and 1, and it cannot exceed those values, at least in the editor. I believe that if you were to go into code and set it to something like 100, that wouldn't stop you from doing that. So this is a purely editor change, but it is nice to know as, let's say, the game designer, what this value is supposed to be. So there's our lerp %. Our hit flash shader is working now, so we just need to make it actually work. And before we do that, let's go ahead and save this material. So I'm going to, we already have the shader saved, but I'm going to save the material as well. So I'm going to save this by clicking the drop down at the material level. Click the drop down, click save, and we can save it in our scenes component directory, but I'm going to call this hit flash component underscore material.tres and click save. And so now we should have both our shader and our material saved. All right, and so the thing that so I'm going to, we already have the shader saved, but I'm going to save the material as well. So I'm going to save this by clicking the drop down at the material level. Click the drop down, click save, and we can save it in our scenes component directory, but I'm going to call this hit flash component underscore material. material.tres and click save. And so now we should have both our shader and our material saved. All right, and so the thing that we're going to do now is we are going to start integrating this. So let's go to our basic enemy scene by hitting Control-Shift-O and opening that up. And this will be the first one we integrate. So what I'm going to do is I'm going to instantiate a child scene. I'm going to instantiate that hit flash component here. Okay, perfect. And we still have our example texture set up. So I'm going to go back to my hit flash component scene and delete this sprite here by pressing delete on my keyboard and then removing that. Okay, so let's go back to our basic enemy. So we've got our hit flash component. Now, this is a node 2D, and I don't think it actually needs to be a node 2D. So let's go and change it. So I'm going to go to my hit flash component. Let's just right click on this right here and click change type. And we're going to change that back to node. So that's our hit flash component. And then let's open up our script, and we have to make sure to change this extends node 2D. This is very important. If you don't do this, the game will crash. So we need to make sure that it extends node instead. Let's go back to our basic enemy again, open up our 2D context up here, and we can close the shader editor as well by just clicking the shader editor button so we have a little bit more room on screen. Let's move this hit flash component up near the other node-based components here, so with all of the other white node types. And here's what we want to do. We want to assign the health component by drag and dropping that health component into the health component property, and then we want to take the sprite and do the same thing for the sprite. So let's go back to our hit flash component scene and open up that script. That material we created, remember that material existed on our little example sprite that we were testing to make sure that our shader worked. So that material describes essentially how the sprite, or that node 2D, and more appropriately the canvas item, how should the canvas item be rendered? That's essentially what a material roughly does. And so in order to be able to do the flash on a sprite, the sprite has to have that material. And so what we're going to do is we're going to assign that material to the sprite that we have a reference to when the hit flash component becomes ready. So let's do that. I'm going to say var, let's say hit flash material. I'm going to use the preload again, so preload, and then we can just look for hit flash material by just typing hit flash and then select the hit flash component material there. So we're preloading in the same way that we preloaded the scene before. We're preloading that material. Then on ready, I'm going to say sprite. I'm going to use the preload again, so preload, and then we can just look for hit flash material by just typing hit flash and then select the hit flash component material there. So we're preloading in the same way that we preloaded the scene before. We're preloading that material. Then on ready, I'm going to say sprite.material is equal to hit flash material. So now when the health gets changed, what are we going to do? We are going to play that flash. And once again, we're going to use a tween for this. So I'm going to say var tween is equal to create tween. And we could end up in a situation where the enemy gets hit multiple times. So let's actually store up here a reference to hit flash tween. And we're not going to assign that to anything, but we can type it so that we know what type it is, and that is going to be of type tween. Okay, so on health changed, what we're going to do is we are going to first check if hit flash tween is not equal to null, and with 2 ampersands, hit flash tween dot is valid, we're going to say hit flash tween dot kill. And so what does this line do? Essentially, if we already have a hit flash tween that is currently running, which is what isValid is, it is valid as a tween that can still be used and is still running, I believe. And we can click into here and see. Yeah, so a valid tween is essentially a tween that is ready to go or is currently running. I'm sure the logic is a little bit different, but you can read the documentation again by clicking into it. But we're essentially saying if the flash tween is still running, we want to kill it, which invalidates the tween. And then we can reassign it so that we don't have two tweens running. So we can say here, our hit flash tween is equal to create tween. Now, what do we want to do? We want to run the tween. We want to tween a property, so hit flash tween dot tween property. What property do we want to tween? This is where things get a little bit complicated. So the object that we want to tween is the sprite, because that's where our material is. Remember, we want to manipulate or change that uniform value that we created. So let me go ahead and open. Open up my hit flash component material here. We want to manipulate this lerp%, which is a property of the material, which is going to be attached to our sprite as we did here. Well, this first argument is essentially what object owns the property that you're trying to tween, and in our case it's the sprite. And so we want to tween the sprite. Now you can go ahead and open up the hit flash component shader, or sorry, the hit flash component material, and if you're curious,
my brain
about
is like
how
blowing up. I can't handle all this information. I'm like dying. My brain gonna go boom boom. This tutorial is so intense. Rah. Holy mackerel, holy moly moly. Okay, keep going. Don't be a wuss, Joe. Keep going. Keep absorbing the information like a boss.
going to be clicking into it. But we're essentially saying if the flash tween is still running, we want to kill it, which invalidates the tween. And then we can reassign it so that we don't have two tweens running. So we can say here, our hit flash tween is equal to create tween. Now, what do we want to do? we want to run the tween. We want to tween a property, so hit flash tween dot tween property. What property do we want to tween? This is where things get a little bit complicated. So the object that we want to tween is the sprite, because that's where our material is. Remember, we want to manipulate or change that uniform value that we created. So let me go ahead and open up my hit flash component material here. We want to manipulate this lerp%, which is a property of the material, which is going to be attached to our sprite as we did here. Well, this first argument is essentially what object owns the property that you're trying to tween. And in our case, it's the sprite. And so we want to tween the sprite. Now, you can go ahead and open up the hit flash component shader, or sorry, the hit flash component material. And if you're curious about how we're actually going to lerp this, what the property name is, you can actually just go ahead and hover over this. And you can see that it's property shader parameter lerp%. Now you can either type that all out, or you can right click this lerp% and copy the property path right here. So I'm going to copy that property path, and then I'm going to paste that for the property that we
Copy property path.
want to tween. So I'm going to put double quotes and then put that path in there. So shader parameter lerp%, and then we want to lerp from, or we want to lerp to 0 rather. And let's say the duration is 0.2 seconds.
This is crazy. So much syntax. My brain is like gonna blow up.
Now you'll notice that we're lerping to 0. We're not actually setting the parameter to 1. So we have to manually set that as well. So let's take our sprite, and then we're going to do .material, .set. Now the thing is,
Hit flash tween.
the material can either be a shader material, or I believe the other material type is, if I take a look at it, yeah, it could be a canvas item material, as shown here, or a shader material. And so because it can be two different material types, we can type this here. So in our hit flash component script, this line that we're editing right now, the sprite material, we're going to cast that as a shader material. Okay, and then we can do, and that has to be in parentheses, by the way. Then we could do .set shader parameter. Now, the interesting thing about this function is that we don't want to include this first line here, where it's shader parameter / we just want to do in quotes lerp%, and we're going to set it to 1.0. So we're setting the value to 1 before we create the tween, and then tween it down to 0 over 0.2 seconds. Okay, and we've got that set up in our basic enemy, our hit flash component, and again, make sure that the health component and sprite are both set, and let's run the game and see what happens.
Mine is not right.
And we're going to set it to 1.0. So we're
Sprite material equals hit flash material. What the hell? I'm probably gonna have to take a break after I finish this flash on enemies. Everything else after this seems really easy. This is the first time we've done shaders, and The tutorial just throws it at you like all crazy.
We're setting the value to
Sprite dot material equals hit flash material.
one before we create the tween and then tween it down to 0 over 0.2 seconds. Okay, and we've got that set up in our basic enemy, our hit flash component, and again, make sure that the health component and sprite are both set, and let's run the game and see what happens. Okay, so first of all of our enemies are white, and we are getting an error. So what is our error? And our error is that there's a type mismatch between initial and final value. Okay, and why is that? Well, that's actually a mistake that I made. This sprite here, remember how I was talking about what is the object that contains the property that we want to lerp? I'm actually slightly wrong about the object that contains the property we want to lerp. The property shader parameter lerp percent does not exist on sprite, it exists on sprite.material. Okay, so this can be a little bit confusing. It even trips me up every so often, but this property exists on the material, and the material exists on the sprite. So we have to specify that we want to lerp the sprite material property shader parameter lerp percent. So let's go ahead and run the game again, and now you'll notice that when we hit an enemy, all of the other enemies turn white at the same time as well. And this can be a very confusing thing for especially people that are new to Godot. So I'm going to try to do my best to explain why this is happening. Okay.
Percent 1.0. If hit flash tween
So this can be a little bit confusing. It even trips me up every so often, but this property exists on the material and the material exists on the sprite. So we have to specify that we want to lerp the sprite material property shader parameter lerp percent. So let's go ahead and run the game again, and now you'll notice that when we hit an enemy, all of the other enemies turn white at the same time as well. And this can be a very confusing thing for especially people that are new to Godot. So I'm going to try to do my best to explain why this is happening. In order to explain that, I'm going to open up my hit flash component material. So this material, in addition to a ton of other things, basically everything in Godot is a resource, essentially. There's slight differences between the types of resources, but when we created our resources up here, our theme is a resource, okay? Our axe.tres is a resource. Our tile set is a resource. If we right click into anywhere and then just go to new resource, these are all resources, okay? And the thing about resources is that a reference of a resource is shared between all scenes that use it. And that means that when you change one instance of the resource, it will be reflected all across the other instances of the resource. And so the situation that we're ending up in is that we are attaching this shader material resource to every enemy, and therefore every enemy is sharing the same material resource. And so that means that when we change a parameter on that resource, it will be reflected everywhere that this instance of the resource is used. So essentially, resources are reused by default everywhere. So if you reference them multiple times, you'll be referencing the same underlying resource. Luckily, there is a fix to that, and that is this button right here. So with the hit flash component material in context here, this property, resource local to scene, is what we want. And this says, if you hover over it, that the resource is duplicated when this is set to true. And what duplicating the resource does is that it makes it a unique instance of that resource, which means that when we change things like the lerp percent, it will only be isolated to this unique instance instead of being propagated across the same instance that's shared among multiple enemies, for example. So we can turn on this local to scene property. Now, the thing about this is that this will not work with the preload strategy that we're using right here in our hit flash component script. But there's an easy fix for that. We're simply going to move the hit flash material up in our script to the exports, add an @export directive here, and then let's go ahead and remove the preload and remove the equal sign, and then we're going to type this with colon, and we're going to use shader material so that we know what type it is, and then that's basically the change that we need to make. Now open up your hit flash component here, make sure it's the standalone hit flash component scene and not the basic enemy scene, and then just go ahead and drag over that hit flash component material to this hit flash material property. Now if we go back to our basic enemy, we can see that this is going to work just fine. It's already pre-populated, and what you'll see is that there's an undo button here, and the thing about that is that that resource local to scene behaves the same way in the editor as it does in game. So if I were to hit this undo, it will revert to hit flash component and it won't have the undo button there anymore. But when I close the scene, that basic enemy scene, and reopen it, because this resource is marked as unique, it's creating a new resource in the editor as well. So that's just a little quirk, but that's nothing to worry about. It's all good. And so now, as long as you've got this resource local to scene checked in your hit flash component material, so this button right here, as long as you have that checked, now our enemies should be flat.
Look how awesome this is. 1 damage, dude. It's freaking cool. Let's do the axe and see how much damage that does. Oh, yeah, the axe freaking destroys them. So I think the way he wants you to do it, I set it local to scene. So I think he wants you to set it to local to scene on the actual. I'm a little confused here. Like I set it local to scene here. But I think he wants you to set it to local to scene here. I don't know, maybe not. I don't see how you can do it here. I guess it's the only, on the shader, it's the only place I see it, so I'm just gonna do that for now.
Flashing
But yeah, my freaking game,
individually instead of all together. Now we still have to implement this for the wizard, so I would encourage you to pause the video and go ahead and implement the hit flash component for the wizard yourself, and I'm going to go ahead and do that as well.
I'll do that later. Bro, look at this, man. This is freaking sick. So I'm also going to change it so the bullet doesn't actually go through them, but I haven't set that up yet. I'm kind of waiting. Our belong to your damage counters are belong to us. What does that mean? A boomer meme from the 90s. All your base are belong to us. Can you link me the meme maybe? I'd appreciate that. Oh, I died, dude. I think I'm gonna take a break. I'm tired and my brain hurts, and he's saying he wants you to all your base are belong to us. At least it has a wiki page. Is that game any good? There's a Darth Vader one. StarCraft's joke. The Gundam Wing version popularized it though. Is Zero Wing a Gundam Wing franchise? Not related. That's a big meme. Wheel of Fortune. I have to kind of take a break. I'm gonna see if I can raid somebody. I'm like tired. Who can I raid? Oh. Can do Unhinged. Let's raid them. RPG Maker Squad. Alright everybody, I'll probably keep working on this off screen. It's hard enough to where it's like not really like stream content because I have to, this shader stuff, it's like hurting my brain. So we're gonna go raid these guys and look at their grapes they made. And I'll talk to you later. Farewell. Good night.
Gone forever. Oh shit, I'm so sorry.
Great, you broke it.
Yep, gone. Holy shit, guys! Now we better kick it into high.